there's a number of these. Awesome, thanks, Doug. So there's a number of these different sample images that you can use when just playing around with parameters, and I encourage you to use them. There's multi-channel images, there's Z-stacks, there's time series, and so all sorts of things to sort of play out, play with these like skills that you learn in these lessons. So if you want to follow along, I encourage you to do so, and we're just using this blobs image first. And this is your brightness and contrast window. I've just opened that up. You don't need to have it open, but I typically have it open. Okay, so last week we saw how we could threshold this image and find these blobs. If these were, let's see if we have a chat, is this? Oh, cool, thanks, Doug. Okay, so in this blobs image, we might want to find these blobs. So let's imagine that these are cells. And so last week we inverted the lookup table so that they were bright objects. You can see as I scan my pointer around them, check up here in this window here, you can see the value for that pixel. So see that these are really the high value pixels, and this background here are the low value pixels. So in a fluorescent image, we're used to having a black background and a bright foreground. And so we inverted the lookup table so that it didn't look backwards to what we're used to seeing. Then we thresholded it, and then we used analyze particles to find these blobs. And analyze some things about, their shape, for example. And so we're going to do that same workflow to start. But the first thing we're going to do is we're going to go into plugins, macros, and hit record. And so you might have seen macros before. Fiji is not the only program that uses the term macro. The idea here is you want to create some automation in what you're doing. So if you're doing 10 button presses or 100 button presses, and you're doing it for 100 different images, or say 100 different spreadsheets in Excel, you might not want to press each of those buttons for each of your spreadsheets or each of your images. And so a macro has the intention of sort of automating that entire process. And so you can imagine even recording where your mouse goes, and that would then be encoded in this macro, and then you could just hit one button, which is run the macro. And so maybe some of you have even used this before, either in Fiji, or like I said, Excel is another example where you can write macros. And that's the idea, is just minimize the number of button presses that you're going to do. So I'm just going to open up the recorder, and it's going to be recording the things that I do. So we'll take our blobs image, and remember the first thing I said is I wanted to invert the lookup table. So I'm going to go to lookup table, and I could just invert the lookup table, or I could choose one that I know sort of makes sense to me. So if I choose this Gray's lookup table, it's going to be like what I'm used to in a fluorescence image, a nice black background for the low pixels and a nice bright white or gray for the high value pixels. And we can see that the recorder has recorded that step. Now remember, this isn't changing the data, it's just changing the way the data looks to me when I see this image. But nevertheless, maybe it's something that I always want to do first, and so this recorder has recorded it. And then we saw how we could adjust the threshold of the image. And there are a few different ways to do this. You can go to the threshold tool, and you can manually choose a threshold with a little slider bar. But Doug showed us last week this auto threshold option. And what he did first was he tried all of them, which gave you multiple different images, all with those different thresholds. And you could see, or thresholding methods, and you could see, oh, that one worked pretty poorly, that one worked pretty well. And what he found was that this Otsu method worked quite well. And this uses a method of trying to separate the image basically into two classes, a foreground and a background. And it would probably, if we look at this histogram here of all the values in my image, it would probably put it approximately there where you have the best spread of the data in both the background and the foreground. So these low value pixels and these high value pixels. So Doug showed us this last week. So I'm just repeating it again and pressing OK, but this time we've recorded it. So here we see it's run auto threshold, and the method was this Otsu method, okay? And now I want to know something about these blobs. I want to know something about their size, about their circularity. I want to know, maybe I want to apply them to the original image and see what the intensity was, the maximum intensity, the mean intensity, things like that. And so we use that analyze particles function. So again, this is, Doug went through this in a little bit more detail last week, so feel free to reference that. But if I go into analyze particles with this thresholded image, then I can do things like set a size criteria. So maybe these small little bits here, maybe I don't want to include those. They came through my threshold, but I think they're maybe too small to be interesting. But I want to capture things that are more or less circular. That doesn't matter to me. I don't want to show anything, meaning I don't want a new image to pop up with some outlines or overlay with counts or anything like that. I don't need that output right now, but I do want to display the results, all the measurements. I want to clear any existing measurements before I do that, and I want to add any regions of interest that I discover with this analyzed particles. So all the outlines of all these different objects, I want to add them to the ROI manager, and I want to exclude these objects that are on the edges because I can't really quantify their shape or their area accurately if they're on the edges. So those are the things that I've chosen, and I'm going to press OK, and it will run. And just like we saw last week, we have a bunch of different outlines on these different objects. We have an ROI manager with all of these objects, and we have our results of a series of measurements that we made on all of those objects. But more importantly for today, what we also have is in the recorder, a recording of this thing that we just did. So we ran analyzed particles, and it has this long sort of statement afterwards that has all of these parameters that I included. So you might not have known how to write out this command here. In fact, it's a little bit funny the way that it's written out, but nevertheless, now we can see how you would do it if you wanted to write it from scratch. So it included this size parameter, size filtering that I put in. It said that I wanted it to display the results, to exclude things on the edges, to clear the existing results, and to add those regions of interest to the ROI manager, which we see back here. So all the things that I clicked in that window, it recorded that and put it here in this macro recorder. And now what I can do is maybe that's it. That's all I'm going to do. I'm going to do that on every single image, and I have 100 images. And I just don't want to have to click each of those buttons and make sure all the right checkboxes are checked. I just want to know that it's run the same way every time, and I hit create. And now what I see is basically the exact same thing. It's just now in this macro editor window instead of in the recorder, but you can see that nothing has changed. There's some new color formatting, but each of these statements are exactly the same. So it's going to do three things. It's going to invert the lookup table, it's going to run this auto threshold with the OTSU method, and it's going to run analyze particles. And so now I could, with every image, so let's pretend we're starting over. I don't need my ROIs. I'm going to close my image. I'm going to clear out all these results. So I'm starting fresh. And now let's pretend this is a new blobs image, when of course it is just exactly the same. But this is a new image, a new data set. And I want to make sure that I run exactly the same thing, and I don't want to have to click all those buttons over and over and over again. And so now all I have to do is press run, and it's going to do all those things on that image. And I only had to click one button after I opened the image. So that is the first, simplest way that you can automate things in Fiji. So I've taken a series of commands, and I've made sure that all those components, all the parameters of each of those methods are encoded in this macro just by using the recorder. And then I've created a macro. I could save this for future use, and all I have to do is open up the image that I want and hit run. And I think that could already be enough for some people. It just makes sure you don't have to press 10 buttons, maybe you only had to press one, and that can already make your life a lot easier. The other motivation that I want to present for this is that it allows for you to have a sort of lab notebook of what you're doing while you're using Fiji. So we don't tend to think of image analysis as part of the experiment for whatever reason. We open up an image, we do a bunch of filters, we test some things out, and then maybe it looks perfect, but we've forgotten the 10 steps that we did to get it to look that way, or to get those results that we wanted. Or maybe it looks near perfect and we wanted to tweak just one of those steps, but we have to do the whole process over again just to tweak that one step. So I want to show you another example of how we could use this to serve as sort of a lab notebook or recorder of what we're doing, and also how by doing that we can allow for like little tweaks in our methods. So I'm not going to save this for now, and again, just close all these things out. And I'm going to open up a different image this time. And this is the confocal series. This is, again, one of the sample images. I just have them loaded in this folder so that I can drag and drop. And I did change the lookup table so that it wasn't red-green, but it is the same as the sample images confocal series. So you could open this on your own computer as well. Okay, and once again, I want to go into plugins and macros and record everything that I'm doing. So, okay, let's pretend that I'm playing around with this image for the first time, and I just want to record what I'm doing so that I can replicate it on future images. And so this is a 2-channel image, and it's also a Z-stack. So the first thing I think I want to do is, oops, not update Java. Let's remind me later. I want to split this into a 2-channel image. So it's already a 2-channel image, but I want to split them into 2 separate windows so I can do separate things on the 2 channels. So I can do image, color, and split channels, okay? Now I have these 2 different windows with my 2 different channels, okay? And this first one, I think I want to apply a median filter, let's say. And so I can process, filter, and I want to do a median filter. This is one that we talked about last week. Again, we did some Gaussian blurring and some median filtering. And so that's what I'm going to do today. I'm going to do a median filter, and I can actually preview before I do it so I can see, if I do this ridiculously high, it's going to look really weird. But maybe 3 pixels is a fine amount. Doesn't really matter. I'm just testing things out, and I'm going to hit OK. And notice, oh, it's going to warn me, okay, are you sure we're going to do it on all 25 images? Remember, this is a Z-stack. And yes, I do. So notice that everything that I'm doing here is being recorded. So it knew that I selected this channel 1 window of the confocal series, and it ran that median filter on that image, okay? And so now I'm gonna click on my channel 2 window, and maybe on this channel, I want to do some Gaussian blurring, okay? So again, I'm gonna process and filter, and I'm gonna Gaussian blur it. And I'm gonna use this scaled units in microns, because that's sort of nice. I can sort of interpret things, pixels. I don't know how big my pixel is, but I know how big a micron is, so perfect. And I wanna do something like 0.5, some relatively modest blurring, and I preview that, and okay, that looks pretty good. I just want to get rid of some of that smaller structure. I just want to see it as a nice green blob. But let's say I accidentally, my hands are shaking or something, and I accidentally forget the decimal place, and I accidentally set my sigma to 50 microns, which is probably way too big, way bigger than I want. But I don't notice. It's a bit early in the morning, and I haven't had my coffee, and so I just say, okay, 50. I think I've put in 0.5, but it's 50, and I just press OK, and I process it. Okay, and I don't notice this has gone wrong, and I'm just going to continue with what I'm doing. The next thing I want to do is I want to put these channels back together, and so I'm going to image, color, merge channels. And okay, doesn't matter, it's going to remember the lookup tables that I have here. I just want to create the composite image. Now I'm back to my 2-channel image. And the final thing I want to do is I want to create a maximum intensity projection. So I go into stacks, Z projection, and do a maximum intensity projection. And I press OK. And now I get my final image out. And this is all I wanted to do. So I'm like, okay, great, create. That's my macro. But I'm looking at this image, and I'm noticing that things look a little bit weird. I don't see my green channel anymore. And so I've finally woken up. I finally realized this isn't quite right. And so let me take a look at my green channel, and maybe I can play around with this slider bar here to change what I'm viewing of how I'm changing this lookup table so that the dimmer pixels in the image are brighter on my screen. And I see, oh, that's what I did to the green channel. So the green channel is still there, but that really huge sigma on the Gaussian blur made things look totally weird. So, okay, if I had not been recording, I would have to reopen the image. I'd have to go through this entire process again and do each of those steps. And I'd also have to remember, oh man, that median filter looks so good on my other channel, but did I do 3 or did I do 2 or did I do 5? I'd have to remember everything that got me to this point. And you can imagine a more complex workflow, that would be even harder. But now all I have to do, and maybe I'm not even, I know that I did the Gaussian blur wrong, but maybe I'm not even sure what I did wrong. And so I can actually look, okay, I recorded what I did. Where do things look weird? And probably this sigma of 50 would pop out to you of like, oh, that's a pretty high number. That's probably where I went wrong. And so I can easily take this and just alter that number. So just turn it to 0.5. And I would have to delete this result because it is wrong. But I could, if I didn't have the original image, I could reopen it, or here I still have this image. And so I could just, oh, actually, no, this is my messed up image. So I do have to reopen it. So let's reopen it. Confocal series. Okay. And now I'm going to hit run. And now, okay, things look a bit better. So that 0.5 sigma is much more appropriate for this image than the 50 sigma that I had before. And so you could even do further testing. Maybe you want to see, oh, well, maybe a slightly lower radius here would also work well for the median filter, or slightly higher. And so you can sit and you can play around with these parameters, and you're just pressing one button other than the key pressing to change those parameters, but you're not having to recreate the pipeline over and over and over again. You've decided on the pipeline and you're just sort of playing around with the parameters. And so I think this is a much easier way to play around with parameters. And it's also a much more reproducible way, because maybe you forgot to do the median filter one time, or maybe you forgot to Gaussian blur the other channel one time. And so this just makes sure that you're annotating what you're doing, and that you're able to go back and redo it over and over again. Okay, are those two motivations clear, or does anyone have any questions so far about just the recording process? No. Okay, cool. Shout them out if you have. Oh, yep. Go ahead.
Hi, Erin. This is Elizabeth.
Hi.
I was wondering, so you mentioned that it will notice like which window, when you split the channels into two, which window you want to perform an operation on. So if you wanted to run this macro on a different image, would that work? Because it presumably would have a different name.
Yeah, great question, because that was exactly the next thing that I wanted to show. So perfect segue. That is an excellent question. So obviously you might want to recreate this entire process on yet another image. So let's close these out. Okay, I've perfected my pipeline. And one thing I want you to take note of is it's recorded all these things that I've done, all this window clicking and closing and whatever. So I can get rid of this recorder and tell it to stop recording everything I'm doing. So, okay, let's imagine that we did another experiment. We took another confocal series, and I have in fact saved this image a second time as confocal series -1. So it's exactly the same image, but let's imagine it's another replicate of this experiment. And so perfect, I have this macro that works beautifully. I just tested it, it worked really well. And now I have it is actually exactly the same image. So, it's two channels, it's the same number of Z-planes, everything should be exactly the same. But when I hit run, exactly as Elizabeth noted, it's going to pop up with an error where it says, oh, there's no window with the title C1 confocal series.tiff. And it is correct, because in fact, there is not that window, but there is a C1 confocal series -1.tiff. So herein lies the problem of just purely recording things. And that is that here I have something that I can't just generalize to any image, because I have some things in this code, if you will, that are specific to the image that I recorded it on. And there's a lot of ways to get around this. There's a lot of ways to write from scratch macros that don't do this. But I'm going to first show you how you would do what I hope are some pretty simple edits of this to make it more generalizable to different images. Because you can see, for example, it successfully did the split channel. So I do now have two channels. It was only when it got to this line here where it had some specifics about what the image was called that it failed. Okay, so what might I do to change this? So of course, every time I run it, I could just edit this. I could say, okay, great, this one's called -1, but look, I'd have to edit it here as well. I'd have to edit it down here twice. So it's not really the best strategy. It is a strategy, But the better thing would be to edit it such that no matter what image you open, it will run this exact process. And I say whatever image you open, but of course, if you didn't open a 2-channel image, it would fail. So I just mean whatever image that had the same kind of data in it, it wouldn't fail. And you can do something really simple, which is just create, instead of this string here, so this string is, the actual file name, you can just create a variable that names the file name. And actually there are some preset functions in the ImageJ macro editor that allow you to say, what is the file name? And so I'm gonna just go to the beginning of this. I could put it after the run split channels, but it doesn't really matter. So if I start typing here, like I wanna know something about the file, you'll notice that actually a lot of auto-complete options come up. So there's all these things I can learn about the file. So, okay, I might want to close the file. That seems maybe useful. I might want to know the directory that the file came from, and I might want to know the name of the file. And so if I go down here to file name, it's the name of the last file opened using the file open dialog, etc. And if I click on this, it actually takes me to a page full of all sorts of built-in macro functions. So although it does auto-complete for you, which is a nice way to guess what you might want, you could also open this page and just search for the kinds of things that you want. And you can see that these are a series of file functions, functions that allow you to get information about a file, read or write a file, etc., create a new directory. And so these are things that'll be really useful if you want to make things generalizable instead of having some specific information about what the file was here. So, okay, the method that we liked was file.name. Okay, so file.name doesn't really get us anywhere, it just gets us the name of the file. But what we might do is maybe create some variables that created this string here. So just file.name. If I put 2 slashes here, this is just a comment. This isn't gonna be anything that is acted upon in this macro. It's just text that I can write notes to myself, like, good job writing this macro. But what this is gonna output is going to be a confocal series, in this case, -1.tiff. Okay, so that will be the output, and it'll be a string. So that will be the output of file.name. But what we want to create is this C1 dash confocal series -1. So what we can do is we can say, okay, what I ultimately want is file.name, but I want to add to it this C1 dash. Okay, so C1 dash is what I want. And I can just actually add that to file name. And that creates, the output of that is now C1 dash confocal series 1.tiff. Okay, and that's exactly what we wanted. Okay, and I could just add this in here. That would be one way to do it, but I could also just create a variable here. This is the channel 1 image, and the channel 2 image is going to be the exact same thing here. Except it's going to be channel 2. Okay? So all I've done here is I've created this string, this string of characters by saying what was the file name that I opened and adding this C1 and C2 to it. Okay? And the other thing I need to do is, you'll notice all these lines have these semicolons after them, so I just need to put that semicolon there. Okay? Cool. So now, very easy, I just replace this with channel 1, and I replace this with channel 2. Okay, and so now I have something that will apply to any image that I open, because I've replaced this text, which was specific to the image that I recorded the macro with just file.name. But there's one more place where we have a problem, which is down here in the run merge channels. You can see I have this big long string, which includes 2 references to things that are specific. This C1 confocal series.tiff and C2 confocal series.tiff. Okay, so this is gonna get annoying and it's one reason why you might notice after some time of working with the ImageJ macro language that you no longer want to write code in this macro language, because it is a little bit cumbersome and there are some points that are a little bit funny about it. And so I just want to make one point, that you don't have to write everything in the macro language, and I will show you where you can change the language of things after you see how annoying this is. So this is one option for how to run merge channels. So this is one long string. And remember, we created new strings up here by just having a string and adding it to some file name or some other string. And so we could do the same thing here. So, okay, we have what we want is C1 equals, and then our file name. Okay, so I'm gonna put C1, that's the first part of the string, and I'm gonna add it to channel 1, okay? And then I'm going to delete what I didn't want. So that's channel 1, I can delete that because that and channel 1 mean the same thing, okay? And now I'm going to put quotes again. Okay, C2, that's fine. And now I want to delete this and instead add channel 2. And we're going to delete this. Okay, great. Plus create. Okay, so I think I've maybe forgotten a plus here. Okay, so C1 equals this C1 confocal series -1.tiff. C2 equals this one here, plus create. And now I have the same string that I had before, but now hopefully this should apply to whatever image we open. So let's test it and see if I've missed any strange dashes or anything. So we're gonna run it. Voila. Okay, so I practiced that so to make sure that it actually worked. Okay, so now I opened up a different image than what I originally recorded things on, and now it works, no problem. It doesn't matter what the image name is. And in fact, I could open up an image that doesn't even have remotely the same name. So here's this fly.tiff. This is still a 2-channel Z stack, but it has a different number of Z planes, so it's different in some ways. And close out these images. And if I run it on this image, it should work in the exact same way. So it doesn't matter that it's called fly.tiff instead of confocal series whatever.tiff, it still works the same way. Okay, but you've seen that this part particularly is weird, and it's fine, you know, it's easy enough to do, but it's a bit weird. So you'll notice these things when working with the macro language, and there's just some sort of funny syntax to it. And so just be aware that you don't have to write everything in the macro language. If you do have experience with other coding languages, I can come up here to language, and I could be writing a script in any of these different languages. And I can also record things, not in all of these languages, but in a subset of these languages. So that's another way to do things. And for some, that might be a bit overwhelming, like how do I choose what language if I'm just starting? That's fine, then just work with the ImageJ macro language. Even these little funny things, they're not that big of a deal. But if you have some comfortability with other scripting languages, then just be aware that you can choose these here. One note is that things like Bean Shell and Groovy, you might see a lot of existing code online. For those languages, they interface really nicely with Java, which is what ImageJ is written in. And another note is that if many of you, I know a lot of scientists use Python, just be aware that you can write in Python in this ImageJ editor, but it's maybe not the same as the Python you've been using. So it's Python 2, not Python 3. That's the version that will interface with Java. And you can't use a lot of the packages that you use in native Python. So things like NumPy that a lot of people use, you can't use that within this editor here. So just be aware of that. But there are actually ways that you can interface with ImageJ within Python if you really want to get fancy. So there are options out there. But if that all means nothing to you, then great, just stick with what we've written here. Any thoughts on that? I know that was a lot of like typing and adding quotations and plus signs. Any questions about that? I have 2 other things to show.
You also add like for loops or something like that?
You can. Excellent question. It's almost as if it was planned. Okay, so yes, you can add for loops. You can even add for loops in the ImageJ macro language. You can add if statements. You can do many of the traditional coding things that you do in any language. And one reason that might be interesting is this right now, although it is now more flexible than what we originally recorded, because we can open up any image and run this macro on it, that's great, but it's not, let's say I have an entire folder of images and I just want to hit go and walk away. It's not going to do that. I have to open every image and hit run, which is still maybe in your definition, not automated. And so what you might want to do is take an entire folder of images and process them all at the same time. And that certainly is a little bit more complex. It would require things like a for loop, for example, where you'd have a list of files and say for each. So if you've never used a for loop, it's basically like, I want to do this 10 times. And so for the first time, do it. For the second time, do it. For the third time, do it. And for all of those 10 instances or however many instances, you just repeat the same process. So that's what a for loop is doing. And so you can imagine why in a list of files, you would for each of those files do some number of processes. Okay, so we could write that all from scratch here, or that might feel overwhelming. So lucky for you, there is a series of templates up here that you can look to for a number of different options. And many of these are written in different languages. And so they're not all, and in fact, many of them are not written in the ImageJ macro language. But down here, there is, under this batch category, there is a process folder option in the ImageJ 1 macro language. So if I hit process folder, it's going to open up a template where I can put my code where there's already this template to process many images in a folder. So this is many more lines of code than what I just showed you. And so I won't go through it line by line, but I just want to point out a few things. So in the beginning here, we see some syntax that we didn't see previously. So anything in green is just a comment. So you can see those as instructions or notes or whatever. But here is some syntax that we didn't see before. This is just creating some parameters in the beginning of the macro that hopefully sort of makes sense. So it's setting an input directory, an output directory, and determining the suffix of file that you want to use. So do you want to use .tiffs or .jpegs or whatever? And so if I hit run, what we'll see automatically is that it opens up this window for those parameters. So choose an input directory, choose an output directory, and say what file suffix you want. So that's what this beginning part of the code is doing. I'm just going to hit cancel. And then the other different syntax that we haven't seen before are these functions. And this is something that if you're doing much more than this, if you're starting to write something that's going to run through many different folders or many different files in a folder, or if you're going to start saving output, even if you just want to share it with a friend and have them be able to run it as well, or maybe edit it for their needs, having some functions in this macro can be really helpful because it helps divide things up. This isn't very long, and so I could look at each of these lines and say, okay, that's splitting the channel, okay, that's selecting channel 1, that's running a median filter. But imagine if this was 100 lines of code and it was just one process after another, it might be really hard to parse what you were doing. But here, I have not, whoever wrote this, this template has created a function called process folder and a function called process file. And so within the process folder function, it's going to get a list of files. It's going to, for that list of files, it's going to say, oh, is it a directory? Well, if it's a directory, then just go ahead and process folder again. So it'll do this function all over again. So you can have nested folders and go through all of them. But if not, and if it ends with the proper suffix, so these are these if statements, then process file. Okay, well, what is process file? Well, it's another function down here, and that function is right now doing nothing except printing. It's processing this file and it's saving this file. But notice this note here, do the processing here by adding your own code. And so now you could imagine that you take some code that you've written and you put it in the process file function. And so now what this code is going to do is it's going to ask for these parameters at the beginning, and then it's going to process folder, which will mean that it goes to the input folder and it then finds all the files that end with the proper suffix and does whatever is in process file. So I know if you've never looked at code before, it's still a little bit overwhelming to look at this, but you can hopefully more easily look through, each of these functions. You know that this is a separate process and this is a separate process, and then you can see, okay, what is it actually asking me to do? Well, it's asking me to process folder. Okay, what does process folder do? And you can step through the code a little bit more easily. And so you can imagine beyond just these functions, you could write a function to filter your images. And then you could have another function that is getting data from your images, maybe analyze particles and getting those results. And so you could have many more functions that you then, instead of pasting a sort of wall of text under process file, you then have some function here that says get data or filter images or whatever the function might be. And then you define those functions later down in the code. So these templates can be really helpful at moving from this sort of wall of text that's just processing a single image, let's say, to actually processing an entire folder of images and really taking you to a fully automated macro. And the last thing that I want to say about this is that what Doug showed you last week and the steps that I've shown you this week, which are really very similar to what he's shown just with some recordings, those are pretty basic level image processing. Not to say that they're not super essential. It's probably something that you do on many of your images, but it's not necessarily getting out all the data that you might need. And there are functions or filter processes that you can find in any image analysis software. One of the powers of Fiji is not the ability to apply a median filter, but actually within this plugins window. So Doug showed you the update sites last week, where you can add in any update site, which maybe gives you some plugins that were written by some research group that's doing something very similar to you. And so you have all these different possibilities of plugins that might do exactly what you want to do for your research. Or maybe they get very close and you just need to add some pre-filtering steps or some further data extraction steps in the end. And so I wanted to note that many of these plugins themselves are also macro recordable. And so just a little preview of what we're going to talk about next week in office hours. We're going to talk about this sort of pixel classification process. So some of you might have been doing this in IntelliSys. Maybe some of you have been using Weka in Fiji. Some of you might have used Elastic. Hopefully these words are somewhat familiar to you if you've done any of this pixel classification. But the idea is segmenting not based on a threshold, but by giving the computer some training data, by telling it, these are the pixels that I want, and these are the pixels that I don't want. And so there is a plugin within Fiji that does this, and it seems pretty advanced, machine learning based pixel classification, and yet it is macro recordable. So if we go into macro record, then we can start recording what we're doing. So I'm going to take my blobs image again. I'm going to go into plugins, segmentation, trainable Weka segmentation, and I'm not going to go through all of this here. I'm just going to show you that it is in fact recordable. So I can add some pixels here. So these pixels are class 1, these pixels are class 2. If you have no idea what I'm doing right now, come to next week's office hours. We'll talk all about this in detail. But what I'm doing is I'm telling it, these are the pixels I want, these are the pixels I don't want, class 1, class 2. Then I'm going to train the classifier, and it trained it, okay, and now I have some output. I have some things that it did pretty good with. I have some areas that it did worse with. Maybe I might add a little bit more training data, or I could save the classifier, and then I'd save it here. And notice that all of this is being recorded. And so, for example, I could instead create a macro. If I go back to my original image, I've saved that classifier. So I probably don't want to have a macro that adds the exact same traces that I've added on other images. That might be a little bit silly. But what I might want to do is record when I go back into my Weka segmentation. And now this time, I might just load my classifier that I've already trained. So I'm going to load in this classifier, and then I'm just going to create my result, and it's going to give me my classified image out. Clearly, I need to do a little bit more extensive training here. But I could create a macro that does, say, these lines here. It runs the trainable WECA segmentation, it calls the load classifier, and then it calls the get result. So on a whole folder of images, I could load the appropriate classifier that I've already pre-trained and then get the result out. And so even an advanced plugin like WECA segmentation, this machine learning trainable pixel classifier, even something like that is macro recordable. Not everything is, but this is just to show you that, you know, one of the powers of Fiji being all these really customized plugins, all being open source, all being actively sort of contributed. Many of them are macro recordable so that you can not only test their features on one image, but then ultimately apply it to an entire folder of images. And like I said, next week we'll go over all these details of pixel classification in a few different platforms. So in Zen, in their IntelliSys module, which is the Zeiss software. So really easy to load your images that you've acquired in the HCBI and do some machine learning based segmentation. Or clearly there's an option in Fiji, and there's yet another, a standalone package called Elastic. And we'll just show you sort of the basics of those and a little bit of what's going on behind the scenes. That is all I have to show you, although I will just make one final plug for resources if you want to start doing this and you get stuck. So obviously there's some information on the ImageJ website. That is a great option. There's also this image.sc forum, which is incredibly active, especially right now that everyone is sitting at home. And I mean, truly, I posted something last week and I got 2 replies from like core developers of the platform I was asking about within maybe 5 minutes. So really excellent response time, but just tons and tons of topics, some about really specific image analysis questions, others about, you know, looking for interesting resources, interesting things to read or things to watch. So really a great community. There's a number of different community partners. So it's not all, you know, Fiji and ImageJ. There's lots of different platforms. We've had the Cell Profiler team come and give a talk recently. So lots of things that you might find interesting. I really like QPath for slide scanner data. And then the other resource that is more recently posted is this New Bias Academy. This is a network that has different like training schools and conferences, and they've recently made a huge effort to get all of this training material online. And so there are a series of talks that might be of interest to the community. So there's one already on the ImageJ Fiji macro language, which seems quite appropriate. This is in just a week or so. I don't even know what day it is, but just in about a week. So you could sign up for this. There's future ones on machine learning, again in ImageJ. IC is another software platform, so lots of options here. So those are just 2 plugs for interesting places to get more information. And of course, we are here to help you with this. So if you have a workflow that's working nicely and you want help automating it, we're happy to do that with you. Or if you want some advice on just, you know, what to do, that's of course what these office hours are for. So with that, I will be quiet. I will maybe stop sharing my screen. And if anyone has questions, please ask.